nice indefinite integral, what's the first thing you might try to do?
Or simplify.
Simplify?
Mm-hmm.
Okay, so what do you want u to be? What do you want u to be?
1 plus cosine.
Well, let's try 1 plus cosine squared x. Okay, so du is equal to 2 cosine x times what? Negative sine x. Dx, thank you. So you know that dx is equal to du over 2 negative cosine x sine x. Sound good?
Yeah.
Looks pretty good. So now you do the substitution. So you end up with what? Sine x over what? U times negative du over 2 cosine x sine x. So there's one nice thing that happens, and then you hit a wall. There's one nice thing that happens, and then you hit a wall. The signs cancel. Is that a nice thing?
Yeah.
Yeah, it's okay. And you can factor out the negative 1/2, so you end up with this. Negative 1 over this, right? Times what, though? What's left?
Negative cosine x
Du. What's the problem here? You have x and u. You have two variables. You have a du and you have a u and an x. At this point, you are sad because you are stuck. You don't know where to go with this. There's nowhere to go. There's a problem. You have two variables here. So what does that... I will tell you that the math, we made this choice, and the math we've done is correct. So if the math we've done is correct, what do we need to change? I'm not asking what you did. I'm asking your choice. All of our math is correct. This is fine, but there's something wrong here, so we need to change our choice. So we're going to use a different u substitution. So what is du going to be? What's du going to be? Negative sine x dx. So dx is equal to negative du over sine x. So now we do the substitution, and what do we end up with? Sine x over 1 plus what? U squared times what? Negative du over sine x. Now, what cancels? The sine x cancels. Okay, so what do we pull out to the front? You get negative 1 over 1 plus u squared du. What's nice about that? It's one variable. Okay, that's nice. It is one variable. And because I might have asked you about things just like this, what is that? That's inverse tan. Negative tan inverse of u plus c. And what does u equal? What does u equal? Cosine x plus c. There's your answer. You get to your single variable and you're home free because you immediately identify that as the derivative of inverse tan. If that's the derivative of inverse tan, what happens when you integrate it? What do you end up with? Inverse tan. Done. Slam dunk. Just because your first u substitution doesn't work doesn't mean there aren't others. Check other u subs. Check other ones. There aren't too many. I mean, you might have tried cosine squared. The problem with that cosine squared happened already, and that you generate like another trig term, and it's floating out there, and that floating out there caused the problem in the first place. So just be careful. Your first job when you're attempting to do this is to actually write the integral expressions, the definite integral expressions. So the first one, they're all from 0 to what? 1. So these are all from 0 to 1, except the last one, which is 0 to pi over 2. And what's this one going to be? Just e to the root x dx. This is going to be 2x e to the x dx. And this one's going to be e to the sine x sine of 2x dx. So these are three different integrals that you need to evaluate. And what you end up figuring out is you get a definitive answer. You get a numeric answer for each of these, and they all come out to be the same. They do. It's kind of cool. It's kind of neat. It's going to be negative 1/2 dx. So dx is going to be what? 2 du times what? 2 du times x to the 1/2, because it's negative, you divide, and it pops up to the top. Exactly. So you make this substitution, and what do you end up with? Well, remember, you have to be careful. You're now in u land, Biggie. You're in u land, so your limits of integration, you have to be careful. U is the square root of x. But what's the square root of 0? 0. What's the square root of 1? 1. So it stays 0 to 1. It stays 0 to 1. But now you have e to the what power? E to the u. And instead of dx, what are you writing? 2 du times x to the what? To the 1/2. What can you pull out to the front? 2, 0 to 1 of e to the u times x to the 1/2 du. And you might think to yourself, man, I have two variables here, but what do you know? What does u equal? x to the half, right? So you can take it and plug it in right there, and what do you end up with? 2 integral from 0 to 1 of e to the u times u du. And guess what? This right here is the exact same thing as they are the same. Remember what I said about labels? It doesn't matter what you call them. Are these exactly the same? They are exactly the same. They're the exact same thing.
All that matters is that it's the same within.
That's why
Correct.
you said
It's the exact
it
same
doesn't
thing.
matter.
So that's why I was prepping you for that. The label doesn't matter. It doesn't matter what you call it, right? It's kind of a cheap trick, but think about it. It is what it is. Okay, so now we just have to be careful on the next one. Pick a u substitution that'll help us. What do you want u to be on this one? Yeah, you have a limited number of choices here because you know at this point you're trying to build e to the x or e to something.
E to the u, so therefore.
Yep. So what do you end up with? Cosine x dx. So dx is
du
cosine, right? So now you go from, what's sine of 0? What's sine of pi over 2? 1, exactly. So now you have e to the u, and instead you have sine of 2x. And then what's dx going to be?
du over cosine.
Du over cosine x. So there's a slight problem here. What's our problem?
Well, sine 2x is 2.
Ah, this is where your knowledge of trig is going to be super important once again, because what is sine of 2x?
2 sine x cosine x.
2 sine x cosine x. If you don't know that, you're totally stuck. At this point, you know that you should know, well, theoretically. Even I forget it sometimes. Sine of 2x is equal to what? 2 sine x cosine x. So if you do that, what do you end up with? 2, 0 to 1 of e to the u. The cosine x cancels there, right? And what are you left with? Sine x du. But what does u equal? U equals sine x right there. So you end up with 2 times 0 to 1 of e to the u du. Is that the exact same thing as we have right here? So they are all equal. You don't actually have to evaluate it. That's a key observation. You might, if you don't actually start working on the other ones, it might get really frustrating because how do you evaluate that? It's not easy. It's not easy. But do you need to know what it is to show that they're equal? No, that was a very good observation. So Biggie, what should our u be equal to?
I have no idea.
How about 1 plus 2x? Does that sound like a good one? Should I do that one?
No.
No, I shouldn't? Nah, I think I should do the square root of 1 plus 2x. Okay. I'm deferring to your expertise. Okay. So 1 plus 2x to the... Okay, so du is equal to 1/2 1 plus 2x to the times 2 dx.
So what happened?
So what happens here? This cancels there. You're right. So what does dx equal? Du times what? To the 1/2. So now when you substitute it back in, it goes from what to what?
Oh.
What does it go from to what to what?
Wait.
It goes from 1 to 9.
To 3.
Oh, wait, 1 to 3, yeah.
It goes from 1 to what?
3.
You plug 4 into this, you get the square root. It's 1, 2, 3 of x over what?
U,
Times what?
u du.
1 plus 2.
No, we haven't. No, you have to do the dx. So it's going to be du times 1 plus
Yeah.
2x to the what?
What happened?
1/2. Well, what is u? I mean, we don't have to. You could, yeah, we can do that. That's fine. But what? Again, it looks like we're stuck. But what's really nice here?
Cancel that.
Yeah. What is this right here?
U.
That is u. So what cancels?
Then it's, so if the
But then-
cancels that.
I know. Hold on. I understand the issues that we're coming up against. So, are we okay so far?
Yes.
But what do we now have? 1 to 3 of what?
X du.
X du. Is that slightly problematic?
Yes.
Yes.
It's slightly problematic because we have a du attached to an x. We really want to get rid of that x. Any ideas about how we can get rid of that x? Yeah.
Solve for x and
Yeah, let's solve for x up here. That seems like a cool thing to do. So what do you end up with? U squared is equal to 1 plus 2x. So 2x is equal to u squared minus 1. So x is equal to u squared minus 1 over 2. So you end up with 1 to 3 of what?
U squared minus 1.
U squared over 2 minus A half. Is that something you can integrate?
Yes.
It is something you can integrate. This is another maneuver you can do, which is if you're totally stuck, remember, you have a relationship by default between x and u. You absolutely do. So if you ever get totally stuck, this is really nice. I mean, the reason this is sometimes hard to see is because it's right. You're so close to it, it's hard to see it, that it's already there. You can cancel. And maybe you'll not substitute and translate the limits of integration, or maybe you'll just keep going. You're like, oh, I'm done. You're actually not. You're really close. You need it to be in terms of u. 1 and 3 are u values. 0 and 4 are x values. So this is just a polynomial. Are you okay with integrating a polynomial? I hope so. What's the answer for 45?
45.
Thomas, tell me what it is.
3x to the 5th over 1 plus x is 9.
It's going to be 3x squared over 1 plus x to the 9. Oh, wait, did I do that wrong?
Yeah, there's
Yeah, you did.
X.
I did?
There.
Forgot.
Oh.
Because of the T.
Oh, because of the t? So it's going to be 3x to the what? 3x to the what? 5th. Oh, you are absolutely right. Good job. I didn't even do it right. Awesome. Because there's well, how do you get that 3x to the 5th?
Well,
It's x cubed times 3x squared. That's how you get the 3x. Good job. Way to catch me on my mistake. Okay, so what's the challenge for 47? What's the problem with 47, Fawn? What's the problem? Why can't you just do that one just like we did that? What's the new thing? Yeah? The bottom. It's not a constant. So what do you need to do to this integral? Make it 2. So you can go from root x to what? What do you want the upper limit to be? 0. Why do we like to choose 0?
you can't do 0
Why not?
because there's a t in the denominator.
Ah, so let's talk about that. Hold on. 0 to x of... So what were you saying there?
This is 0 and the first one is negative.
Yeah. So 0 to what?
0 to root x.
And it's going to be?
Negative.
So what is y prime going to be? E to the x over times what? Times what? Yeah. 1/2.
Oh yeah. No. No.
Oh wait, am I not?
No.
Whoa! What?
Times
What? Hold
1.
on. I am tired or something. I don't know what's going on here. What am I plugging in for t?
Root x.
Root x. Thank you. So it's e to the
Root x.
root x over,
Root x.
and then times what?
The derivative of root x.
Yeah, 1/2 x to the.
Negative.
Yep. Plus, and what's this one come out to be?
E to the x.
Over
X. Times 1.
times 1. So are you done? Yeah. The key here, well, you're sort of done. It's only it's asking you if you're done here. I mean,
Yeah.
the only you can this be cleaned up a little bit?
Yeah.
Sure. I mean, x to the negative 1/2 is 1 over the root x. So what does the denominator become?
X.
Becomes x, right? So can you? Yes, the 2 is also there, so it becomes 2x. But the point is, can you clean this up a little bit? Sure. This is the derivative, though. This is the derivative. What happens to this area right here? It's negative here and positive. So what happens?
Gone.
It's gone. It cancels out. And what are you just left with? A to B. The positive part, exactly. The one you want. So it doesn't matter. It's okay if you don't even have to check. It doesn't matter where it is. Why do we like 0? Well, sometimes we have to plug in the number, so maybe it'll help. How do you do the first one?
0 is equal to 1 plus secant theta.
You like u is equal to 1 plus secant theta? Because what does du become?
Secant
Theta, tan theta. Yeah, so that's a good start, isn't it? I'm not going to finish it, but that's a great start. Now, what about this one? What's the challenge for this one?
The first one or second?
The second one. We're not going to finish this. That's all you need. It works. You can go and do it.
System of Equations.
You need how many?
2.
You need 2?
Yeah.
Yeah. Or 3?
You,
Just 2, because it's going from 0 to 3. Yeah. Okay. So you're going to go from 0 to what?
0 to 2.
0 to 2. And from 0 to 2,
It's negative.
it's negative. So you have to turn it into negative. Yeah, I will. I'm just going to do it out. Negative x squared minus 4 dx. And then what are you adding to it?
2 to 3.
2 to 3 of just
X squared.
minus 4 dx. Yeah, you can flip it to make it 4 minus x squared. I see that. But the key realization here is, what does this look like? Well, what does x squared minus 4 look like? There's x squared minus 4, right? Where there's negative 4. What does that absolute value do? It does that. So you're really looking at this plus this right there. You're looking at those two regions added together. What happens if you just ran the integral from 0 to 3? Would it be positive or negative?
Negative.
It's going to be negative. But if it's an absolute value, you'd be like that. There's a problem. There's a slight problem there.